Good day, everyone. We are now going to discuss another sample problem. We have a parabolic curve here. According to the problem, we have a series of uniformly spaced hangers along a parabolic cable ABC, and it supports a water supply line, and the allowable tensile load in the cable is 1,100 kilonewton. So the first question is, we are going to determine the maximum tension at the support if the sag is 2 meters. And second question, what is the minimum sag of the cable? And the last question, what is the tension at the lowest point of the cable if it is stressed to its allowable tensile load? So if we are going to identify the given data in the problem, the length from point A to point B is 60 meters. That is the length of the parabolic curve from point A to point B. And that the parabolic curve supports a water supply line, and the load given in the problem is 2.8 kilonewton per meter. By the way, this is the figure which was given already in the problem. So we have the allowable tensile load provided, which is 1,100 kilonewton. The first question is, we have to determine the maximum tension at the support given that the sag is 2 meters. So that's why we have here H is equals to 2 meters. So to answer the first question, we are going to determine the maximum tension at the support if the sag is 2 meters. So we have to determine the maximum tension, and that the condition is the sag is about 2 meters. So if we are going to take summation moment at point A, and we are going to set this to be equal to 0, then we will be able to find out that based on the equation, you can draw, let us draw first the diagram. So if we are going to draw the figure for this half of the parabolic curve, this is the height, and then this is half of the 60 meters. That is a total of 30 meters. Then we are going to determine the resultant force here, and we are going to represent a force H here. So if we are going to take moment at point A, we will have the value for the resultant. The value for the resultant here is 2.8. That is kilonewton per meter. And then you are going to multiply it by the distance, which is 30 meters. So that is 2.8 is equals to 30. And that's equivalent to 84 kilonewton. So the unit of 84 is kilonewton for the value of the resultant of the weight that has to be supported by the parabolic curve, which is 2.8 kilonewton per meter. So if we are going to take moment at point A and representing a force H here in the parabolic curve, then we will have 2 times H. That is the perpendicular distance from point A times H. That would be equal to 2 times H equals to, you have the 84 kilonewton here, and that the perpendicular distance from point A is 15 meters. So that would give us a value for H, which is equals to 630. Now, in continuation, if we are going to make use of the Pythagorean theorem to determine the value of the tension, if you are going to represent or draw a free body diagram for the forces acting in the parabolic curve, you would notice that we have here 84 kilonewton going down. And then of course you have the value for H here, which is 630. By the way, this is 84 and this is 630. And then by drawing the force polygon, we will have here the value for, let's say we represent this as the value of the maximum tension when the sag is at 2 meters. So that gives us the equation using the Pythagorean theorem. Tension squared is equals to, you have 84 squared here, plus, of course, you have the 630 kilonewton squared here. With that particular equation, we will be able to determine the value for the tension. And that gives us 635.48, 635.58 kilonewton. And this is our answer for the first question. Now let us go to the second question. The second question is, what is the minimum sag of the cable? So we need to determine the minimum sag of the cable. And how do we represent the sag? So if you are going to take note according to the problem, the allowable tensile load in the cable is 1,100 kilonewton. So since that is the condition, then that means if we are going to represent the allowable maximum tension using again a force polygon here, we represent here 84, which is the resultant. Then of course, you have here the value of the force, horizontal force, which is unknown to us because now the condition is minimum sag of the cable. That means instead of using a value of P here, we are going to use the given condition, wherein the maximum tensile force is 1,100 kilonewton. So with the use of this force polygon, we can continue again with the same Pythagorean theorem. But this time we are going to use H squared because that is the one that we are going to determine, is equals to, you have 1,100 squared minus this time 84 squared. Going back into the Pythagorean theorem, that is simply c squared is equals to a squared plus b squared. And in this particular case, the value of c is 1,100, the value of a is 84, and the value for b is h. So that we will have the value for h here, which is equals to, by calculation, 1,096.79. But that is not yet the answer to the second question. The second question is regarding minimum sag. So with the use of the same procedure, if we take summation, moment at A is equals to 0, and this time using the condition that we had here, so the value of H this time will be equals to 1,096.79. And then of course, we have the value of 2 here because that is 2 meters. But now that is the one in question. So we need to determine the value of H, or the minimum sag of the cable. Okay, so that's minimum H. Let's identify that as minimum H. And it can be equated to the same. You have 84, which is the resultant force here. And then of course you multiply by the perpendicular distance, which is equals to 15 meters. And by the use of calculation, we will have the value for H, which is equals to 1.15 meters. So this will be our answer for question number 2. While this one is our answer for question number 1. Okay. So the last question is the tension at the lowest point of the cable if it is stressed at its allowable tensile load. So that means if the condition states that at the lowest point, and then the allowable tensile load is applied, so that means we have a stress of the allowable tensile load. That means the value of H that we are going to use is 1,096.79 kilonewton, or round it off, 1,097 kilonewton. So this will be our answer for question number 3. Remember that the question in number 3, or the last question, is regarding the tension at the lowest point with the application of allowable tensile load of 1,100 kilonewton. So that means instead of using the 630, our answer should be 1,097 kilonewton. Okay, so that will be the end of our video tutorial regarding parabolic curve. I shall see you in my next vlog. This is Dr. Ramela B. Ramirez once again. God bless everyone.